Well, welcome back to another episode of the Biohacker Blondie Podcast. We are going to get into a subject that is very confusing to everyone, genetics. And it has been a journey for me to kind of even understand genes, raw data, what we do with it. A lot of people can even get some testing done and they still don't even know what to do. So I'm so excited to have Aaron on with DNA Labs, and you are a DNA expert. And I did your whole system, DNA Labs, and I was highly impressed because I've done quite a few, and a lot of them don't provide great information, or you're confused and, what do I do with this information? So you guys just have an amazing platform that lays it out and tells you all your gene variants and what to do about it. So thank you so much for coming on the podcast. And if you can give a little introduction, and let's get into genes.
Yeah, thanks for having me. Always happy to chat with you. So yeah, my name is Aaron Goldman. So my training is in molecular biology and genetics. So I have a PhD in those topics. So importantly, I'm a scientist, but I'm not a clinician. So I'm not a functional medicine doctor or naturopathic doctor. I'm a pure scientist, but I do have a team of practitioners that we work with as well. Yeah, and basically we do two different types of DNA testing. One type is really more about medication compatibility. So if people are on any drugs, a lot of drugs don't work, and you might need a higher dose or a lower dose. So that test really looks at how your body deals with medications, and it's sort of a prescribing tool for prescribers that say, if your patient has a certain genetic variant and you want to prescribe, codeine, then maybe you want to avoid codeine and prescribe something else because the person can't metabolize it. Or you might want to prescribe this other drug at a half dose or higher dose to fit the person's genetics. So that's a technology called pharmacogenetics, pharma meaning drugs and genetics meaning genetics. And it's a technology that's been around for a little while. Our offering is called Match My Meds, and we cover over 170 different drugs. Basically swab your cheeks, send it in to us, and then within a week you'll get a report that has a breakdown of all those medications, which ones will work, won't work, what drugs need a higher dose or lower dose based on your genetics.
Wow.
Yeah, and that was the first test that we developed when we first launched our company about 10 years ago. It's
with
a great
DNA Labs?
Labs, exactly, yeah.
Okay.
So it's a great test. I've seen it help a lot of people. We're now testing in various hospitals, both in Canada and the US. We're working with the Hospital for Sick Children in Toronto, which is the number one pediatric hospital in the world, according to Newsweek magazine. So we do their pharmacogenetics testing. But, after we launched and we started doing a roadshow, trying to sell the thing, we realized drugs just don't work in a lot of cases. There's a lot you can do with prevention, so you don't need a drug in the first place. And a lot of that prevention can be informed by genetics. So that led us to develop our other type of test, which is a nutrition and lifestyle test. That's one we did for you. And we have like a direct-to-consumer version that people can buy on our website. But most of what we do is we sell the pro version through practitioners.
Well, it's so cool. I actually know someone who did the DNA for medication. How common is this for a physician to say, hey, before I give you medication, let's do a DNA test?
Yeah, it's a great question. So not enough.
I know.
I should have mentioned that. I should have mentioned at the beginning. I'm actually up in Canada, so our company has an office here in Canada and another office down in Florida. But so we are an international company. But in Canada, it's a tough sell because if the government doesn't pay for it and all healthcare is paid by government, it's a tough sell for individuals that they don't want to pay for anything in healthcare. A lot of doctors in Canada don't even know how to take a credit card because they just do everything billing through the
insurance,
private payer. Yeah. So not enough. There are some cases, like there's one drug that's called Plavix, or that the brand name is Plavix. The drug name is clopidogrel. This is a blood thinner that's given to people after they have a heart attack or a stroke, or if a stent is put into their system. So it's a blood thinner that's supposed to thin your blood so that you don't clot again and you don't have another heart attack or a stroke. And amazingly, like 40% of the Asian population can't metabolize it. It's about 30 to 35% of the Caucasian Europeans can't metabolize it. So this has sort of become the poster child for this technology because the Surgeon General for the state of Hawaii, a state that has a very large Asian population, actually sued the makers of Plavix, and that led the FDA to put a black box warning on the drug. So, before you're prescribed that drug, you have to get your genetics understood because it's not going to work for a lot of people. The analogy I like to use, it's like it's like you're driving and you think you're wearing your seatbelt, but you're not, and you're about to crash. That's sort of what's happening with these people. So that's one example, but we cover various therapeutic areas. Mental health drugs are really notoriously difficult to get right. So the anti-anxiety, antidepressants, for pain medications, gastroenterology. It's a complete drug.
I feel like it could be life-changing for someone making sure they're on the right medication per their DNA.
Yeah.
I think this should be with every prescription. I mean, anxiety or depression medication and everything. It's just if you could be completely wasting your time or wasting years on one medication that could actually be hurting you.
Yeah, absolutely. And there's people that are on antidepressants and you don't know if it's working for about a month, and then a month later you're realizing it's not working, so you have to stop taking that drug, and then you have to wash it out for a month or two and then get prescribed another drug. It's this whole trial and error process. And in the meantime, especially with depression, people have suicidal thoughts. It can be really
important to make sure you're on the right one that's helping you instead of hurting you.
Exactly.
Is it an expensive test? I know these DNA tests run around a few $100s. Is it the same for prescriptions?
We tried to be very competitive in terms of our pricing. Just pulling up our website because I know it is $350 in Canada. It's $275 in the US.
Okay.
We do sell. It's called Match My Meds. You go to our website, dnalabs.ca, and then it's $275 US or $349 in Canada.
And would they have to go through a doctor, or could they just order on the website?
In the US, you do need a doctor to sign off on it. So you can order from our website, but then during the registration part of the test, you basically scan a QR code that's in the kit and you fill out a form. One of the questions is, who's your doctor? And you put in the doctor's email address. The doctor will get a little button that says approve. They just click approve and that's it. So it's really simple.
I didn't think we were going to get into DNA for prescriptions, but anyone out there, which a lot of people are taking prescriptions, might want to do this. And it's not talked about enough, and it's so important.
Absolutely, yeah. And we just updated our panel. So as I mentioned, we cover over 170 different drugs. And with this latest update, we actually improved the turnaround time as well. So once we receive the sample, the report's delivered within about 7 days.
Wow, that's amazing. So should we get into what is DNA?
Yes.
And what are gene variants? Because I think what, are SNPs, what are all these terms?
Yeah.
So if you can just give us a breakdown before we get into the whole panel of gene variants you guys offer.
Yeah, for sure. So you might have heard the term genetic code, which is basically, it's all the information that's stored in our DNA that makes us who we are. And we actually have, if in every cell in our body, or every cell in our body that has a nucleus, you can pull the cell off your body. It's microscopic, you can't even see it with the naked eye. You put it under the microscope. Inside the cell, you'll see a nucleus, which is a little circle in the middle. Inside the nucleus are a bunch of chromosomes. So we have 23 pairs of chromosomes. You might have seen that structure sort of looks like an X. What the chromosomes are in every cell that has a nucleus. So, like for example, red blood cells don't, but yeah.
And so, how much? So we have, and how many cells do we have? We have trillions of these, right? So it's just
we have trillions of cells, and if you're able to take the
DNA.
Yeah, so we actually have. So I have numbers for this that'll blow your mind.
Let's hear it.
So if you take all the DNA from one cell, so if you're able to unravel, basically the chromosomes are DNA wrapped around little proteins. So if you're able to unravel all the chromosomes in one cell, it'll be about 2 meters long. It's actually one of the most amazing things our bodies do is it packages 2 meters of DNA into this microscope.
One cell.
And it doesn't just crumple it up and throw it in there. It has to be very organized the way it's packaged because, you have to access the DNA to turn genes on and off. But anyway, so that's 2 meters per cell. So if you extrapolate that to your whole body, to trillions of cells, we have, I think it's about 61 billion kilometers of DNA. I have a slide. I can't remember what that is in miles, but it's enough to stretch from the Earth to the sun and back.
Wow.
So it's a massive amount of DNA that we're walking around with.
Yeah. So that's why it was kind of just discovered in 2020 or 2000. And then we've just been incorporating more and more information.
Yeah, we've known about DNA a bit longer than that, but absolutely the Human Genome Project was the project that sequenced the whole thing. So we actually read one person's DNA from beginning to end. And it's actually about 3 billion letters long. So the DNA is made up of letters. So just like the English language has 26 letters, the language of DNA has 4 letters, so A, T, C, and G. You might have seen like a bunch of genetic code represented with those letters. So those letters basically spell out, information that make you who you are. And we have 3 billion in our genetic code, times 2, because we have 1 copy from mom and 1 copy from dad. So we have 6 billion letters of DNA in each of our cells.
Oh my gosh. Yeah. And I think that's what it's so even hard to comprehend what you just said. It's like,
Right.
wait, what? And you have these letters and it's very confusing for people. And you have now these gene variants as well. And then you can turn your DNA off, you can turn your DNA on.
Yeah.
So I don't even know where to start.
Yeah, so I can explain. Yeah, so basically the DNA, so it's 3 billion letters long, A, T, C, G, C, A, T, G, and so on. But it's organized into sections that are called genes. So you have one section that's called a gene within the middle of this piece of DNA. What the gene does, it's almost like, you can look at it, an analogy I like to use, it's almost like your whole DNA is like a cookbook. Each gene would be like a page of the cookbook, which is a recipe, right? It'll have instructions on how to make that certain meal. So a gene is kind of similar. The gene sort of makes instructions on how to make a protein, which is really what does everything in our body. So that protein could be a hormone, which guides development. It could be, a transcription factor, which binds to DNA and turns other genes on and off. It could be a transporter, a protein to move nutrients around, or an enzyme to like break down like the medication, for example. An enzyme that breaks down medications. So the genes make the proteins or encode the proteins. The proteins do everything in our body. Now, you might have heard the term the statement that humans are 99.9% genetically identical. So you and I are 99.9% the same if we look at our DNA. So that means we're only 0.1% different. But remember, we have 6 billion letters in our DNA. So 0.1% is actually about 6 million. So between the two of us, we have millions of differences in our DNA. And those differences make us who we are. So if you go back to the recipe analogy, let's say my recipe calls for, a double
flour
amount of
and eggs, and mine is vegetarian or vegan.
Right,
And I only
exactly.
use
Yeah, or it
almond
could be
flour.
when we're talking about genetic variations, it's actually one little change in the DNA. So it might be that, your recipe calls for 1 egg, mine calls for 2 eggs. You can see how a little change in the recipe could change the outcome. It'll change the meal, right?
Yeah.
So that's kind of similar. Like the genetic variants are encoded in our DNA, and then it sort of can be used to understand how our proteins are different and how we function differently.
And there's so many things that it involves. I don't think people realize how their gene variants are affecting their daily lives, how they're eating, the food, their nutrition, physical fitness. A lot of people struggle with cardiovascular health, which could be their genetics or nutrient deficiencies. So a lot of these gene variants can be impacting everyone's health on a daily basis. And it can really change your life once you know your gene variants. We can get into the MTHFR gene, which is very common. And so we'll just first break it down. I just wanted to go over your panel so everyone knows that you have gene variants that work on the heart health, food sensitivities, nutrition, physical fitness, brain health, detoxing, obesity. I don't know if there's a few others, but
Hormonal health.
you guys break it down to really help people say, hey, if you do this based off of your genes, you can change your nutrition or things that can really impact, or detoxing. And so some people might I guess we could just start with detoxing, because that's a big one that I don't think people realize, especially in 2026 now, we're surrounded by toxins.
Yes.
And some people cannot detox as well as others. So can you explain the genes that are affecting detoxing?
Yeah, sure, absolutely. Yeah. So one of the big ones that we look at is the glutathione detoxification pathways. So I'm sure people that are regular biohackers would be
Just
familiar.
repeat, because a lot of people were in the space, but a lot of people are not.
Yeah. Okay. So anyway, so glutathione is a molecule that basically acts as an antioxidant, and my understanding is you have a toxic molecule your body wants to get rid of. Our glutathione genes, are the genes that we look at, make a protein that actually takes glutathione and sticks it onto a toxin. So it's basically tagging the toxin with glutathione Now that toxin with glutathione attached to it becomes water soluble, and you can pee it out. So it can be removed from the body. So how we tag those toxins is encoded in our DNA. So we look at a bunch of genes. They're called GST enzymes. So glutathione S transferase is the longer term. But we have a whole bunch of these in our genome. We have GSTP1, GSTT1, GSTM1 that we're looking at. So if people have variations in their GST enzymes, it means they might have a reduced ability to tag toxins. So the toxins can build up over time. And what we've seen, or what the research shows, is that if you have variations in these genes, your inability to detox could lead to illness later in life. And it's usually it takes time to build up the toxins over time. So, a newborn baby with these variants is not going to have the same kind of toxic exposure as like a 40-year-old firefighter, right? Or a mechanic, or someone living in a very moldy house or something like that, right? So
and something you can do is take glutathione. There's supplements. You can do IVs or injections of glutathione. So if you have this gene variant, then you can take more action and realize, hey, I need to increase glutathione. And it's also important for the brain to have glutathione in the brain, which can also prevent some
neuroinflammation and stuff like that.
Yeah. So that's a big one.
Yeah. For
and sure. What about histamine?
Yeah, histamine's another one that we look at, and that's actually been helpful for me personally because I have seasonal allergies. So I learned from my report what foods to avoid and what foods to focus on. I'm not supposed to be eating the dried fruits or avocado or
based off of your genes.
Yeah, so we look at two genes. One's called HNMT and one's called DAO, and these genes basically are associated with or can be indicative of whether someone's sensitive to histamines. So if they are, they should avoid foods that contain histamines or release histamines.
Do you do a histamine-free diet because of that?
I should. I don't. What I've done small tweaks. I've stopped eating like pickles and fermented foods and beverages.
Interesting. So no sauerkraut for you or kimchi.
Exactly. Yeah.
Some people are, I guess I have to ask, in Japan or China, do they not have this gene variant?
Yeah, it's a great question. And so they do have the gene variants in other countries. Sometimes the distribution is a little bit different, so it might be less common amongst different populations. But yeah, no, it's a good question. I should look into that one.
I know. And so many people are struggling with histamine issues. So this is a big one. And then if you are people more sensitive to like wine, I know that can cause a lot of histamine reactions, or alcohol. Would that be because of this gene variant?
It could be, yeah. So definitely there's histamine and all those, anything that's fermenting like alcohol would be sort of a bad food to take. We also do look at alcohol directly, so we look at a couple genes that are related. It's in the same section, just a couple pages over. We look at alcohol. So some people are, slow metabolizers of alcohol. So when they drink alcohol, the alcohol is not cleared out very quickly, so it stays in their system. So sometimes they might get the more pleasurable effects of alcohol quicker, so they're more likely to have alcohol use disorder. Some people are fast metabolizers, so they can drink more and not get sick. There's a gene for alcohol flush reaction. So again, this is mostly only in the Asian populations, but sometimes they drink and they get flush reaction, like a red skin.
And is that processing an enzyme? Because I know also like with Asians, I think it's common gout. Is that also due to genes?
I'm not sure about the gout, but it is a gene. It's alcohol dehydrogenase. It's an enzyme that basically breaks down alcohol. And if you have a slow version of that, then the alcohol is not going to get broken down.
I think I have a fast version. I don't drink anymore, but before I could drink quite a bit.
We can look on your report and see.
I know. Should we do that? Should we go through the report?
Sure, yeah, if you'd like to.
Okay, well, it's here.
Yeah,
so this is all my DNA. I'm just giving it to everyone.
Right. Yeah, so this is the web-based version of the report. And actually, so you bring up a sort of a good point. A lot of people are really nervous about DNA, and they don't want to know if they have a risk for a disease, or they don't want an evil insurance company to get a hold of your data. A couple of points on that. So first of all, this test that we're doing here is importantly not a disease risk test. We do cover a few diseases like late onset Alzheimer's disease, hemochromatosis, and things that could lead to diseases. But we look at it almost like they're more lifestyle diseases. So even the Alzheimer's risk and we can go through this as well. But the Alzheimer's risk gene is a gene that encodes an enzyme that breaks down the fat plaques that build up in your brain over the course of your lifetime. So if you have a slow version of that gene, those fat plaques are more likely to build up over time. But it's not a gene that says if you have the gene, you're going to get Alzheimer's. That's not what it is. It's because there's so much you can do. Understanding that if you have the risk, there's so much you can do to minimize your chance of getting sick down the road. It's actually a very valuable piece of information. So it's not a disease risk gene. It's a gene that indicates you might need some support in certain areas. You might need to do a bit more detox, or you might need to avoid certain things, or
foods, histamine foods,
yeah, exactly.
or alcohol if you're not slowing, or even certain how you guys. There's certain things like iron. I'm not able to absorb iron as well, and when you're nutrient depleted, then that can lead to your body not functioning correctly and can lead to disease. So that's why a lot of these gene variants can be so preventative if you know what to do.
Yeah, I think iron is a good example. If you want to go through that, I can walk you through.
Yeah, let's go through because it's so cool, everyone. Oh my gosh, I love the whole platform.
Yeah. So this is the web-based version, and you also get a version of the report that's a PDF that you can download and print. But I like the web-based version, a little easier to navigate. So as you can see, we use this card approach. So you can see all these different cards that are in the report. So we have a card for iron, and a card for omega-3, and a card for choline. And if you scroll down, there's a whole bunch of other cards in this section. There you go.
Oh my gosh.
Yeah. And so you can click that plus sign reveals a paragraph that's at the top of the card. And that's boilerplate text. That's the same on everyone's report. So if you click on the one next to iron there at the top, if you go all the way to the top, there's a plus sign beside the word iron. Yeah, there we go. So that paragraph there, that's boilerplate. It's the same on everyone's report. In this case, it's just talking about how important iron balance is in the body. But most importantly, right in the middle there, I'm sure it's a bit hard to see for everyone, but we describe what symptoms to look out for. So symptoms that are associated with having too much iron and symptoms that are associated with having too little iron. And I'll come back to that in a second. And then if you see where it says take action, everything from there all the way down to the bottom is tailored to Jenny based on her genetics. So it starts off with the take action on the top, which is really the key take-home message. And then there's a little section that says why, and it has a bit more context. And then at the very bottom of the card, it has a section called It's in Your Genes. And that's where we talk about all the different genes that we're looking at. We describe what versions of the genes you have and what it means for your health. And then at the very, very bottom, we actually provide a table with the genetic results for people that want to dive a little bit deeper.
So can you explain the C, the G, the C, T, P, A, A for everyone? Because I've always been like, what does this mean?
Yeah, absolutely. Yeah. So as you can see in this table here on the left, there's 5 rows. So we're looking at 5 different genetic variations, which are also called SNPs, SNPs. So 5 different genetic variations that influences how our bodies deal with iron. And then you can see the names of the genes are listed above. So there's a gene called HFE, where we're looking at a SNP. There's the second row also says HFE, so we're looking at another SNP within the HFE gene. So we're looking at 2 SNPs within that gene. And then we're looking at 1 SNP within the TF gene, 1 SNP within the TMPRSS6 gene, and 1 SNP within the TFR2 gene. So those are the gene names above. And then in brackets, underneath the gene name, is the name of the SNP. So it's basic, and I look at this almost like a zip code. If you remember from school or from what we were just talking about before, a gene is a long string of letters made up of DNA. So that RS ID number, it's basically like a zip code. It tells you about a specific location within the HFE gene, right? So you'll see the top one there is RS1799945. That's a specific location within the HFE gene. And now at that location, you can have a C there or you can have a G there. So the typical value is C and the atypical value is G. Importantly, we don't, like I said, all these variants that we're looking at are actually pretty commonly found in the population. So it could be 20, 30, 40% of the population carry these things. So it's not exactly abnormal or mutant. So we use the terms typical and atypical, where the typical one is associated with the quote-unquote normal outcome, and the atypical one is associated with some sort of outcome that we might want to address. And then under where it says your results, there's 2 letters there, because as I said before, you have 2 copies of every gene, one from mom and one from dad, right?
Mm-hmm.
So in the HFE gene, so if we're looking at the top 2 rows in the table, at the first location, the typical is C and the atypical is G, and it looks like you have 2 typical Cs. So you have a C from mom and a C from dad, right?
Mm-hmm.
Likewise, at the other location within the same gene, on the second row, the typical is C, the atypical is T, and again, you have 2 good Cs, or 2 typical Cs. So together, that tells me that you have the good or the normal version of the HFE gene, right?
Mm-hmm.
What does that mean? So HFE is the gene that's associated with iron overload or hemochromatosis. Because you have the normal.
Did not have that issue at all.
That means you're not at risk. And if you look at the last paragraph just above the table, it says you have the typical or normal version of the HFE gene, and therefore you're not at risk of iron overload or hemochromatosis. Right? Mm-hmm. Make sense?
Yes.
Yeah. So now,
Perfect.
If we move on to the bottom 3 rows, variations in those 3 genes are associated with iron deficiency or too little iron. And right away you can see you have 1 good, 1 bad of the first one. I'm going to use the term bad, but just understand there's no real bad information in this report. It's just the simplest, you have 1 typical, 1 atypical of the first one, 2 atypical of the second one, and then two normal ones of the third. So it's really those 2 genes, the TF gene and the TMPRSS6 gene, that enables us to say, hey, Jenny might have a risk for iron deficiency, right? Because you have those genes. And if you scroll up a tiny bit, you'll see the text it's in your gene section that basically says you have atypical versions of genes and a risk for iron deficiency. And it's bolded there. Now,
and I've seen that in my blood test results many times.
Yeah. So, and importantly, just because you have this risk doesn't mean you're experiencing iron deficiency symptoms right now. You're going to have this risk for the rest of your life. You've had it for your whole life. But now that you know about it, there's something you can do about it. So now if you scroll up to the top of the card, we can go back to that boilerplate text. And if you look in the middle there, it'll say iron deficiency is characterized by the following symptoms like extreme fatigue, weakness, chest pain, shortness of breath, poor appetite. So if you're not experiencing those symptoms, then just keep doing what you're doing. But if you are experiencing those symptoms, then, hey, it might be due to an iron deficiency, and then you can go get a blood test to confirm.
Yeah.
So you really have to listen to your body. You have to take the genetics into account with other things you're feeling, but it can be really helpful in terms of pointing you in the right direction.
It is. For me now, I know too, I did the test, blood testing and was iron deficient. So now I know I need to eat some more red meat, or I need to supplement and to keep my iron levels and my ferritin at a good level. Yeah. So it's kind of like the blood work and the DNA kind of go hand in hand, and you can see almost like they work together. Yeah. Can we talk about the omega-3 fatty acids? Because I think that's a big one for people, especially if you're vegan.
Yeah, no.
How that works.
Yeah, for sure. Actually, before I move on, let's just go back to the take action under the iron.
Okay.
Because we stick to dietary guidelines. So the report there says you might need 8 milligrams of iron in your diet. But you see that word iron is a hyperlink, so you can actually click on that word, and it takes you to food sources of iron. So it really does show you what foods,
nice,
what portion size you should aim for, and so on. And if you scroll down there, it goes into the organ meats, which are rich in iron and stuff like that.
Oh, nice. Yeah. I didn't know that.
Yeah.
That's perfect. Wow, you guys have an amazing platform.
Oh, thank you. So let's move on to omega-3s. And actually, it's hard for me to read on your screen, so I have yours open here, so I'm going to just open it up.
Okay.
Yeah, so for omega-3s, so the first line that it says there, it says you can choose to consume plant-based sources of omega-3s or animal sources. But
some might not be able to.
Yeah, a lot of people are not able to, exactly. And then the second bullet there, it says you're likely not at increased risk of obesity or metabolic syndrome when your omega-3s are too low. If you scroll down to the genes, we can look at why we're saying that. So So actually, it looks like here for omega-3, you have two typicals for all three genes. So you have the typical version of the FADS2 gene, which is the first one, and then you have the typical version of the IL-6 gene. We're looking at two different markers there, and you're normal for both, or typical for both. So the IL-6 gene is an inflammatory marker, and that's the one that indicates if people have variations there, it might mean that they have an increased risk of obesity and metabolic syndrome if their omega-3s are insufficient, or if they're not consuming enough omega-3s in their diet.
Mm-hmm.
So for you have the normal version, so you're not at an increased risk of metabolic syndrome or obesity, but it's always still good to make sure you have those good fats.
Good omega-3. Yeah, for sure.
And then that FADS2 gene at the top there, again, you have the normal version of that gene, but that gene basically is involved in taking the plant-based omega-3, like that you get from like flax seeds or chia seeds, which are called ALA, the alpha-linoleic acid. So that gene basically converts that into the, quote-unquote, animal-based, or the animal version of omega-3, which is the DHA and the EPA. So because you have the normal version of that gene, that means you can eat flax seeds and you'll be able to convert them into DHA and EPA no problem. So,
but if someone has two atypicals, then
exactly. So they could eat flax seeds and it's not going to convert into the EPA and DHA. So if they're vegan, then they're probably not getting enough omega-3 in their diet. They can eat a truckload of flax seeds and they still might not have enough omega-3 in their diet. So the recommendation for them would be to either consume fish oils, or if they're vegan and they want to maintain that lifestyle, there is a vegan source of EPA and DHA which you can get. It's like an algal oil.
Okay.
So if that's the case, it would be
which is very important. Low omega-3s, brain shrinkage, it can definitely hinder you in the long run.
Exactly.
So this would be very good if you have if you're vegetarian or vegan.
Yeah. Exactly.
Then we go into choline, which I have.
Yeah.
What are some others? Probiotics. I don't know. We can also talk about vitamin A because that's a big one for people, I guess, if you're vegetarian or vegan.
Yeah, and vitamin A is actually a very similar story to the omega-3s. Here we're looking at a gene called BCMO1, which stands for beta-carotene monooxygenase 1. It's a bit of a mouthful, but basically what this enzyme does is it takes beta-carotene, which is this long, funny-looking molecule, it basically cuts it in half and sticks an oxygen at the end of it. And what you get out of that is active vitamin A, or retinol. So it's basically taking beta-carotene that you're consuming in vegetables, like orange vegetables, like carrots and sweet potato, and leafy greens like spinach. So when you eat a carrot, you're taking in beta-carotene. Your body has a gene called BCMO1, which makes the BCMO1 enzyme, which basically makes vitamin A out of the beta-carotene. Now, a lot of people, it looks like yourself included, have variations within the BCMO1 gene, which means that you're going to have a reduced ability to make the vitamin A from the beta-carotene. So now, if you're vegan and your only source of vitamin A is coming through that pathway, then you better hope that your BCMO1 gene is working. But if it's not, then you can eat a truckload of carrots and your skin will turn orange before you have enough vitamin A in your system.
Wow.
So the recommendation is to either rely on animal sources of vitamin A, or if you're vegan, you can always supplement, but you have to keep in mind most supplements actually have beta-carotene in it and expect you to convert it into vitamin A. So that's not going to be helpful. You're going to want to look for a supplement that has retinol in it or active vitamin A. And that's what it says, basically.
Good to know. That's so good to know. Yeah. I don't think a lot of people know about that gene variant. Yeah. So here, are we getting into the MTHFR gene?
Exactly,
the vitamin B. Okay, let's talk about that, since I still am shocked that supplements and folic acid is in our food system and everything, when I think a majority of people have this gene variant.
Yeah. So exactly. So this is one that's been popularized by a lot of people on social media and stuff like that. So the MTHFR. But there's a whole pathway there. So we don't just look at MTHFR, we also look at MTRR, MTR, COMT, FUT2. These are all different genes involved in the methylation pathway. And basically it's like the MTHFR, for example, is involved in converting like folate into methylfolate, or LMTHF. And if you have versions of these genes, which means you're going to do that a bit more inefficiently, then you're not going to be able to process, folate into methylfolate. That might it might eventually lead to an increase in homocysteine, because homocysteine is part of that whole pathway. Don't want to get too too into the weeds.
I know it's a lot, but basically it can cause inflammation, I guess. Homocysteine is inflammation, so if you're not methylating these vitamins correctly, then that leads to inflammation.
Exactly. Yeah. So the report would have helpful hints in terms of what type of supplement to buy. If you're going to do B12, whether you need the hydroxycobalamin or the methylcobalamin version of B12.
Yeah.
And that sort of thing. So it can be really helpful when you're looking at the whole pathway.
And a lot of people say, I mean, they think it's 60% or even more people have these gene variants that can be.
It's really common. We've seen a lot of people, but some combinations lead to like a massively reduced amount of activity. Some lead to like only a slightly reduced amount of activity. So it depends on what combination you carry. There's going to be a tailored recommendation for you.
Okay. There's vitamin C. Should we go to the next category? Should we talk about physical fitness?
Yeah, so this first one here is all about, it's called exercise recovery, which is really interesting. So everyone has inflammation when they exercise. Some people can clear that away quicker than others. So here we're looking at a bunch of inflammatory markers like C-reactive protein, interleukin-6, insulin receptor, TNF-alpha. So we're looking at a bunch of inflammatory markers, and as presented here in the context of recovering from exercise, because that's where the studies were focused on. But a lot of practitioners like to look at this section if they suspect that their patients or their clients have high inflammation. This might explain why. And as I might have mentioned before, everything on this report is actionable. So there's always going to be something you can do about it. So even if you are at a high-risk category for inflammation, there's always going to be something recommended, whether that's lifestyle, like getting enough rest between sets at the gym, or natural products like omega-3s or NAC. These are things that can be helpful in terms of reducing that inflammation. There's always going to be something listed. There's always something you can do about it.
Yeah, that's the great thing about knowing your DNA, is that you can use it to your advantage.
Exactly.
Is there any genes where I might be wanting to do more like less high intense, more muscle building?
Yeah.
Are there certain genes for that?
Yeah, definitely. Like we do have a section there, like endurance versus power. It shows you which type of exercise you're more suited to based on your DNA. There is a gene, actually it's in the exercise recovery section, called SOD2, which is involved in cleaning up it's that bottom one there. It's involved in cleaning up the oxidative stress or the free radicals that are generated during oxidative stress. So sometimes high intensity exercises could lead to more of that stress. So there might be a caution there. Now it looks like you have one good, one bad, which is actually I believe that's good. Like I think there's just genetics can be complicated, and sometimes a trait is dominant, sometimes a trait is recessive. So if a trait is recessive, you actually need two bad copies in order to be at risk yourself. Whereas if it's dominant, then one bad copy is enough to have the quote-unquote bad outcome. And again, I keep saying good and bad, but it's really just for simplicity's sake. There's no real bad information on this report.
Okay. What about pain tolerance? That's a big one for people. So
that one actually is the COMT gene. So you might have heard of this gene before. It's part of the methylation pathway. It's a methyltransferase. We talk about this gene actually in a bunch of different parts of the report. We talk about it here in the context of pain tolerance. We talk about it in the context of methylation with the B vitamins. We talk about it in the context of brain health with the worrier and warrior gene, which is we can get into as well.
Yes.
It also regulates estrogen, so it's talked about in the hormonal health section as well. So it's involved in a lot of places. Here we're talking about it specifically in the context of pain tolerance. Maybe we can talk about it more in the context of the worrier because that's sort of related to this. But basically, people that it looks like you have the normal version of the gene. The way I like to think about this gene So it stands for catechol-O-methyltransferase. So it transfers a methyl group, or it methylates catechol molecules. Catechols are things like hormones and neurotransmitters, so like dopamine, for example.
Mm-hmm.
So basically what this enzyme does is it takes a methyl group, which is a carbon and a bunch of hydrogens around it, and it sticks it onto dopamine, and in doing so it makes dopamine inactive. So it's basically turning off dopamine signaling, right? And the way I like to think about it is, you have a thought in your brain, a bunch of dopamine is pumped out into your synapses. This enzyme comes in and cleans up all that excess dopamine so you can stop thinking about that thing and move on to something else, right? Now, it looks like you have two fast versions of the gene, right? Two normal or fast versions of the gene. So that's associated with the worrier version of the gene, which is you have a thought in your brain, the dopamine's cleaned up really quickly, and so you can stop thinking about that thing and then move on to something else, right? Now, and that relates to a higher pain tolerance as well, because, the dopamine
Doesn't last like
is
in
really quickly.
processing.
Exactly.
Interesting.
Yeah. Whereas, yeah.
Do you think someone who has maybe more anxiety would have the worrier or
Yeah, exactly. So I actually have, so my version of this gene is CT. So I have one good copy, one bad copy, or header. And when it comes to pain tolerance, the studies actually show that that's similar to the worrier. So I should have sort of like a normal or a high pain tolerance, which has been true. I've noticed that over my life. But the CT heterozygous version that I have is also associated with the worrier version. So it's slower when it comes to cleaning up that dopamine. Again, I have a thought in my brain, a bunch of dopamine is pumped out into my synapses, and then my enzyme is a slower version, so it slowly clears the dopamine away. And as it's being cleared away, my brain continues to fire, continues to overthink things, maybe dwell on things, maybe stress out about things. So I tend to have higher levels of stress, but sometimes worriers do better at cognitive tasks because we actually think things through, whereas sometimes a worrier has trouble focusing. So it's really all about balance. And the great thing about this, knowing this information, is that it's modifiable or actionable. So for myself, if I'm a worrier, if I'm too much of a worrier, this enzyme actually uses magnesium as a cofactor. That's why I have some magnesium on my desk right here.
Which magnesium do you use during the day?
This bisglycinate version.
The glycinate. I can only take it during at night because it
Yeah, I take it in the evening.
Okay. So yeah, the COMT is very, very interesting. Like, I think it's so cool for people to realize, if they process dopamine correctly. I was just listening also to a podcast about your chronotype, and that is also a gene that can affect if you're a morning person or a night person.
Yeah.
Is that on here?
We don't talk about it in that context, but we do have a couple of genes on here. There's one called clock and the one called period, and they are involved in circadian rhythms. We talk about them in various other contexts. One is like the timing of meals. So people are more likely to have obesity if they have their meals too late if you have a certain gene variant.
Yeah, it was really interesting because it does, I guess I'm the lion, and it also can influence your melatonin, your cortisol. I don't know the specific gene he was talking about, but I do think people have this like certain genes where they are like I am a 4:30 a.m., 5 a.m. person, and then I've pushed myself to go out at nights, but honestly, like I love to go to bed early and wake up early, and then exercising. I mean, it's really when you dial down your DNA and work with your system and your body and the food like off of what you're supposed to do, it's like you can really change yourself. And not trying to fight it, And I think too with society, like we always, you have to wake up at this time and go to school at this time. But they were even saying too, like based off of your chronotype, like, you can really, maybe some people are at their best, at 9 to 11. Some people can be at their best later in the evening, So everything is very, very personalized. Like we're getting more and more into personalization and saying, instead of saying this one medication or this one food is good for all,
Right.
it's really kind of, we're realizing that we're all different based off
Yeah.
of our 6 million
Yeah.
different DNAs. So, so what is the mood? What is this one
Yeah.
here? So this is the brain
Yeah,
health.
so this is the brain health section. So yeah, we look at mood, addiction, memory, stress. Yeah, so the one just below this one is the worrier that we were just talking about.
Okay.
That's cognitive performance and stress resilience. The mood one is kind of similar. So we're looking at a gene called MAOA, which is a gene that is also involved in breaking down or stopping neurotransmitters.
Mm,
And yes, and then it could lead to, if you have like a slow version of the gene, it could lead to slow breakdown of neurotransmitters. So you might have too like levels that are too high in your system, which could lead to aggression and other mood disturbances. If it's too
interesting.
low, it can lead to other issues. So, yeah, so this is a section. It's really important that you have to listen to your body. So, for example, like for myself, I'm a worrier. I know I know that I'm a worrier, but I don't have to take magnesium all the time. If I'm not feeling stressed, I just keep doing what I'm doing. I think that it's always best to try to get nutrients from foods instead of supplementation if you can.
Yeah.
So if I'm like eating healthy and feeling good and sleeping well, then there's no need to run out and get a supplement. So you have to really listen to your body. And then
Are you more of like ashwagandha, L-theanine, magnesium? Are those your go-tos?
yeah, for sure. Like I do have I have all of that at home. So I've dabbled a little bit, but yeah, honestly, I now I just take like a multivitamin with methylated B vitamins
Mm,
based on my genes. I take omega-3 and magnesium. Those are the big ones for me, I would say.
yeah. So let's get into the Alzheimer's, since I know that one's a big one too, the
Yeah,
ApoE.
yeah. So this is probably the most sought after piece of genetic information that's out there, or one of the most. Yeah, it's a gene called ApoE. So it stands for apolipoprotein E. Lipo meaning lipids, which is a fat. So basically, what this enzyme does is it breaks down fat plaques that would otherwise build up in your brain over the course of your lifetime. If you have a certain version of this gene, then that might mean that you have an increased risk of late onset Alzheimer's disease. And it's specifically late onset because it hits you very late in life, because it takes a lifetime to accumulate the fat plaques over time. So it could be your
Mm,
70s, 80s, 90s even. But again, if you understand that you have the risk at a young age, like if you have one bad copy of the gene, that's associated with a threefold increased risk. If you have two bad copies of the gene, that's associated with like an 8 to 12-fold increased risk. So pretty significant. But
is this pretty common? I get it for people to have a gene variant for the ApoE?
yeah, it's pretty common. So there's three versions of the genes that you can figure out from these the two SNPs that we're looking at. There's one called E2, one called E3, and one called E4.
Mm,
It looks like you have two copies of E3, which is E3 is the normal one, or the one that's most common and associated with a normal level of risk for Alzheimer's. The E4 is the slower version of the gene, so that's related to Alzheimer's risk. And E2 is actually, I look at it almost like a faster version of the enzyme, or a more efficient version. It's actually neuroprotective. If you have the E2 allele, you have a lower than normal risk of Alzheimer's, but it is associated with a cardiovascular condition as well, which is laid out in the report.
you can't
So
win.
yeah, you can't win, but I think the protection that you get from the neuroprotection you get from the fast version of the gene probably outweighs the rare cardiovascular disease that's associated with it. But you can't choose your genes. You gotta live with what you're dealt.
And
But
the
yeah,
thing
so
too, like with gene variants, these are the like what we've only discovered so far. So there's more to discover, right?
yeah,
So
tip of the iceberg here for sure. Yeah, absolutely.
yeah.
Yeah,
So we're just at the very
yeah.
tip of or the
Yeah, but anyway, so the reason why this one's so powerful is because if you did have the Alzheimer's risk gene, there's so much you can do. So there's diets that are recommended. There's certain things that you should be including in your diet, like flavonoids. There's certain things to avoid, like smoking and saturated fats and excess metals and stuff like that. Being
The
active.
thing with this, though, is, I mean, everyone should do that. I mean, this
Exactly.
isn't just for people who might have, more likely to have Alzheimer's. So I think, like, I really do like the specific gene variants that are like more, hey, don't eat so many carrots,
Yeah,
eat more like fish or meats that
exactly.
you're getting But these, like even the breast cancer, the BRCA and the others, it's
Yeah.
kind of like, well, stay away from sugar, eat a Mediterranean diet.
And yeah, and I always tell people you should be doing these things anyway, but
Yeah.
sometimes some people need that motivation. Seeing an increased risk of Alzheimer's on a piece of paper can actually be really motivating. For
Yeah.
people. So, but I agree 100%. You should be doing these things all the time, and the information might be might reinforce the idea that you should be doing these things.
Yeah, I mean, a lot of this, a lot of these things, the histamine is different. The sulfur, the charred meats.
Yeah.
Everyone loves their barbecue, but I
Yeah.
guess some people should not.
Yeah, there's toxic. There's toxins found in the charred bits of meat that can be harmful to us, and some people can clear that away quicker than others.
So definitely, I don't know what gene is this?
Yeah, so this is CYP1A2. It's actually the same gene we look at for caffeine, so in the coffee section. So
Okay.
yeah, so and it looks like you have one good, one bad, so you're a medium metabolizer. So
Okay.
the caffeine example is a bit more straightforward. So so I have the same as you. I'm a medium metabolizer, which means let me just talk about the extremes first. So if someone's a fast metabolizer, so they have two fast copies of the gene, they can drink coffee after dinner and they break down the caffeine really efficiently and they can sleep like a baby. Whereas if someone has two slow versions of the gene, that means that they're slow at processing caffeine, so that they might drink a coffee and they don't break it down, so it stays in their system. So they get jittery. If they have a coffee day, it might keep them up. For me, my personal experience, if I drink coffee too late in the day, then it might keep me up.
Yeah.
But I can have two coffees before before like 2 o'clock, and I'll be fine. So it really depends. And that's sort of consistent with a medium metabolizer, which is what I am. So does that sort of fit with you? Do you drink coffee at all?
Yeah, and I think it's one of the best biohacks is not drinking coffee. As like I stay away after the morning or 12, and then especially they always say 2 because for most people it lasts in their system like 6 to 8 hours. So it's a lot of people will drink caffeine later in the evening, and it's one of the worst things you can do because then it's like this cycle of not getting good sleep. Then you're tired the next day, and then you're drinking more caffeine, and it's like so one of the best biohacks I'm gonna say out there is to stop drinking caffeine at least by 2 p.m. Like
Especially if you're a medium or slow metabolizer.
yeah, and then if you're slow, like you probably need to bump that to like 10 a.m.
Right. Yeah, exactly.
What is this sulfur removal?
So there, yeah, we're looking at a gene called CBS. So it's just another one of our detox pathways. So it's an enzyme that helps convert, I think it's homocysteine into cysteine, if I remember correctly. It's
Okay.
and yeah, if you have a slow version of the gene, then your removal could use a bit of support, basically.
Okay, so we have some obesity risk. So everyone who, I always feel bad because when I do see people that are overweight, I'm always thinking, and this reflects back to my testing is that I have low leptin levels. I'm not sure if this is part of it, but that is, you're not, basically the leptin is saying you're not as full, correct?
Exactly, yeah.
Yeah, it is interesting to see these obesity risks as part of your DNA. So it's not fair for everyone.
Yeah. Yeah, but again, there's always something you can do about it. So yeah, like exactly the first card there, regulation of appetite. We look at two genes, MC4R and FTO, and these genes are, yeah, like if you have a certain version of the gene, then you don't feel full So you sort of keep eating. So again, knowing that, you can sort of remind yourself to sort of take breaks when you eat. I find just eating slower can help. Or
eating more vegetables, eating foods that are lower calories, higher, consumption of food that you can fill yourself up more, is important. Also, is this fat? A lot of people ask, should I be eating saturated fat or more of a fatty diet? So is this the gene that affects how we process fat?
This one's more about preference.
Okay.
But in the diet and heart health section, we look at fat. So you can
Okay.
you can actually, if you go to the categories at the top, and then click on the diet and heart health at the very top, like up above. Yeah, there we go. So that if you click diet and heart health, that'll take you to the first section.
Oh, the fat consumption.
So the first card there is really talking about genes related to fat consumption.
Okay. And then we could go on forever, so I'm just trying to, let's get into the hormonal health before we end.
Yeah, sure. Yes.
I really think this is great for people so that they understand their thyroid, their testosterone, their estrogen, especially testosterone for men. I don't think they realize, I think there's the free testosterone, and then some might not convert that as well, but I'm not sure for this. Is this as my sex hormone?
Yeah. Yeah, exactly. SHBG. So that's it binds to dihydrotestosterone, DHT, and certain versions of the genes are associated with having lower levels of free circulating testosterone. Yeah.
That's a good one to know. Thyroid.
Yeah, thyroid is looking at overactive, underactive thyroid. TSH levels are associated with that. And then in female reports, as you can see, there's 3 different sections about estrogen. So we have estrogen detox through the glutathione pathway, which we talked about at the beginning.
Yes. Okay.
As well as through the methylation pathway, which we also talked about. And then the estrogen metabolites is actually phase 1 detox of estrogen, looking at if someone has a risk of high or low levels of different metabolites. So when your body needs to remove estrogen, for example, there's all these versions of estrogen that are created in the meantime. And they're called metabolites. Some of them retain estrogenic activity, so they still act like estrogen, so they can be harmful if you're supposed to remove them and you don't. Some of them are protective. So it's important to have a good balance, and your DNA would tell you basically what to expect or what your genes are most likely associated with. And then you can do a urine test or a blood test that looks at real-time levels of hormones. You can do that type of test periodically to make sure the levels are where they should be. But your DNA can help you understand your predisposition and then your interventions as well. It can guide
Amazing.
You.
Yeah, this whole platform is so great. So there's some genes you guys didn't include, like the BRCA gene, right, or certain. Why did you decide on this group of gene variants and not include all of them?
Yeah, it's a great question. So first of all, with BRCA1 and 2, these are genes that are strongly associated with breast cancer, breast and ovarian cancer, and they sort of made famous by Angelina Jolie a couple of years ago. But we tried to make our test first of all common variants that everyone has. When guidelines say that we need 1,000 units of vitamin D, that's based on a whole population. But there's common variants that might, if we look at them, we might be able to understand. Some people might need more, some people might need less, right? So it's really more of a lifestyle and common things. With BRCA1 and 2 specifically, and then just to take a step back, the technology platform that we chose is called genotyping, and it's not sequencing. So we're looking for specific markers that the literature has shown is statistically significantly associated with certain outcomes. So if the papers say there's a G at this location which is associated with iron deficiency, then we're looking for that G, right? With BRCA1 and 2, the way you do the diagnosis or the way you do the analysis is actually sequencing through the entire gene. So you're reading every single letter of the gene. So you're not just looking for a G, you're looking for every single letter, which is thousands. So for that reason, we want to keep our costs down and really only focus on variants that are common. So we use a technology platform to allow us to do that. If we wanted to sequence, we need a lot more. We couldn't do it from a cheek swab. We'd have to get blood. We'd have to do a whole sequencing analysis, which would be a lot more expensive. So
that's why. Interesting.
Yeah, so we sort of stayed away from a lot of the disease risk is also more complicated, so it requires input from genetic counselors or medical geneticists. So we sort of stayed away from that sort of disease risk, other than, as I mentioned before, the lifestyle diseases like the late onset Alzheimer's.
Interesting. So for anyone out there, is data being sold? Everyone's worried about, with 23andMe, all their data is given, they're going to make twins or something, and I don't know what they're going to do with it, but is this something that people should be worried about?
No, so we're very clinical grade. With 23andMe, the reason they can sell the data is because they're actually collecting a lot more data than they're giving to you, right? When you get a 23andMe report, they talk about your ancestry and maybe a few health-related things, but they're actually collecting hundreds of thousands of data points on you. And that data is useful for, discovery work. So they partner with big pharma companies and they try to do discovery work based on that data. For us, we're only testing the genes that we're delivering to you, and they're common variants that everyone has. So it's not really valuable for a third party to do any research, so we don't sell it. But even beyond that, we wouldn't sell your data without any consent. We would only provide the data to the person purchasing the test and or to their healthcare provider if they do it through the...
Okay, well, that's good to know, because I think a lot of people definitely are worried about that.
Absolutely. We get that question a lot. We have a one-pager that we're happy to send to people if people have any questions about how we handle privacy.
Okay. So if anyone wants to go order this test, find DNA Labs, where do they go and find you?
Well, so I think the pro version of the Love My Health, which is the report we just went through on yours, I think people can get it through you, and then maybe they can get a consultation with you to walk them through it, if you're willing to do that.
Yes, of course. Yeah. I'll provide the link and everything in the show notes.
Yeah.
And then they can go to your website, DNA Labs.
Yeah, and then they can go to our website if they want to just purchase the standard direct-to-consumer version or the the medication one that we talked about at the beginning. Okay,
and that's also there.
Yeah.
Okay. Amazing. Well, thank you so much. I think we went over almost all of it.
Yeah.
We could probably spend another hour or two going through the whole everything specific, but I think everyone can see how the platform works and how beneficial this can be to their health. So it's really, and thank you so much for taking the time and explaining everything and kind of breaking down DNA and gene variants, because it's very confusing for people. Yeah. So I'm hoping this helps.
Yeah, I hope it's helpful. I hope it wasn't too technical. I know it can be confusing. I usually show slides that make it a bit easier.
No, this was great. So this was good. So,
great.
And then I'll upload this on YouTube for everyone to see. And so, yeah, thank you so much for coming on the podcast.
Yeah, no, thanks for having me. If there's any questions, I'm sure people can find me through our website or through you.
Okay, perfect.
Awesome. Thanks so much.